So we need to resolve the given rational fraction into its partial fraction. Let us begin. Now here we see that we have a biquadratic term in the denominator, which is x raised to the power of 4 plus x squared plus 1. Let's try to simplify this. We can also express it as, so x raised to the power 4 can be expressed as x squared whole squared. Now, instead of taking x squared, what we'll do? We'll take 2x squared. But that's an extra term. So what we'll do? We'll keep the constant term as it is. So we are going to subtract x squared from it because 2x squared is an extra term here. Now, in doing so, what you can see here, that this is nothing but the standard a plus b whole square formula. So here we have x squared plus 1 whole squared. That means x squared whole squared plus 2x squared plus 1 is the expansion of x squared plus 1 whole squared minus x squared. Now immediately in doing so, we can see here that this is the difference of squares. Difference of squares, we know if we have a squared minus b squared, so that's nothing but the product a minus b multiplied to a plus b. So here we can use the difference of squares to expand this to get x squared plus 1 minus x multiplied to x squared plus 1 plus x. So that means we now have 1 over x raised to the power of 4 plus x squared plus 1. So this can be also expressed as 1 over the product of x squared plus x plus 1 multiplied to x squared minus of x plus 1. Yeah. So now what we have? We have now factorized the biquadratic factor into two quadratic factors. That let this be equals to two partial fraction. So here we have the first partial fraction. We'll come to the numerator part in a moment. X squared plus x plus 1. And the next partial fraction, the denominator portion, will be x squared minus x plus 1. Now, we usually start with the constant term a in the numerator. However, x squared plus x plus 1, that's a quadratic factor. So we'll have to consider ax plus b. Similarly, for the second partial fraction, the denominator, we have a quadratic factor. So we'll have to consider plus the numerator portion as cx plus d. So now our goal will be to determine the value of a, b, c, and d. Let's label this as equation number 1. We'll proceed as usual. What we'll do? We'll take equation number 1 and multiply both sides with this factor, which is x squared plus x plus 1 multiplied to x squared minus x plus 1, such that we get 1 equals to, we have x squared minus x plus 1 multiplied to ax plus b, plus we have x squared plus x plus 1 multiplied to cx plus d. Right. So let's simplify the expression on the right hand side, and we're going to combine all the like terms. So that's going to give us x cubed multiplied to a plus c. So that means a plus c is going to be the coefficient of x cubed, followed by x squared multiplied to negative a plus b plus c plus d, plus x times, the coefficient of x will be a minus b plus c plus d. And then we have the constant term, so that will be b plus d. Now, the first term consists of x cubed, the second term consists of x squared, the third term has x, and the fourth term is the constant term. Now, if we look at the left hand side, we only have a constant term. We do not have any term containing x cubed, x squared, or x. But what we can do, we can rewrite it as 0 times x cubed plus 0 times x squared plus 0 times x plus 1. Now this is done so that we can equate both sides. So if we equate both sides, so on equating, we get a plus c. So that's the coefficient of x cubed on the right hand side. This will be equals to the coefficient of x cubed on the left hand side. So that's simply 0. And then we have negative a plus b plus c plus d. So this is going to be the coefficient of x squared on the right hand side, and the coefficient of x squared on the left hand side, that's 0. So this gives us another equation. Next we have the coefficient of x, so a minus b plus c plus d. So this is also going to be equals to 0. And coming to the constant term, we have b plus d equals to 1. So here now we have 4 equations. So let's all label them as number 2, number 3, number 4, and number 5. So clearly we have 4 parameters here, a, b, c. Clearly we have 4 constants a, b, c, d, and we have 4 equations. So we can use the 4 equations to obtain the value of a, b, c, and d. Now I'm leaving that as an exercise for you to try out. So a will be equals to positive half. The value of b, that's going to be equals to positive half as well. C value will be equals to negative half, and d value is positive half. So now we have the value of a, b, c, and d. All we have to do is replace this value back in equation number 1. So let's do that. So equation number 1 will now give us, so we have 1 over x raised to the power of 4 plus x squared plus 1 equals to, so we chose ax plus b. That means we chose half x plus b divided by x squared plus x plus 1. Then we have negative half x plus half, so this divided by x squared minus x plus 1. So this is the required partial fractions. So we have successfully resolved the given original rational fraction into its constituent partial fractions.